Hi, I am Dr. Liana, an emergency medicine physician and metabolic disease researcher. I have spent years studying the frontier of beta cell biology, the gap between what the research reveals about pancreatic regeneration potential and what patients are actually being told about their options. What I found when I went deep into the literature was not a single miracle ingredient, but a combination of three green plant compounds that work in a specific synergy, addressing different layers of the beta cell failure cascade simultaneously, a combination that no pharmaceutical agent currently replicates. Let me first explain why the conventional approach to type 2 diabetes misses the most important biology. Most people with type 2 diabetes are managed primarily through insulin sensitization, meaning medications that help existing cells respond better to the insulin that is produced, or through insulin supplementation, meaning adding external insulin when the pancreas can no longer produce enough. Both approaches manage consequences without addressing the underlying process driving beta cell loss. And the process driving beta cell loss is not primarily genetic, and it is not simply the inevitable result of having high blood sugar. It is a specific and increasingly well-understood cascade of metabolic injury that, the research shows, can be addressed through targeted nutritional intervention if done early and consistently enough. Think of your pancreatic beta cells as a factory district with a fixed number of highly specialized production facilities. Each facility produces insulin in response to blood glucose signals. When that factory district is operating normally, it has enormous spare capacity and can scale production up and down with extraordinary precision. When the metabolic environment becomes consistently hostile through chronic high glucose, elevated saturated fatty acids circulating in the blood, and elevated inflammatory cytokines, those facilities begin to struggle. The machinery inside each factory, the mitochondria that power insulin production, becomes damaged and inefficient. The endoplasmic reticulum, where insulin protein is folded and packaged, becomes overwhelmed. Oxidative stress accumulates inside the cells. Inflammatory signals begin triggering apoptosis, programmed cell death. And the remaining healthy factories are forced to run at overcapacity, trying to compensate for the ones that have been lost, accelerating their own decline. This is beta cell failure in mechanistic terms. And stopping it requires addressing the specific injury processes, not simply compensating for the reduced output. The green drink protocol I am about to describe uses three ingredients that together address this cascade. The base is fresh or frozen spinach combined with cucumber, both providing specific compounds beyond simple nutrient density. The second component is a specific amount of freshly ground fenugreek seed. The third component is moringa leaf powder, a plant that has been used medicinally in Ayurvedic and traditional East African medicine for centuries, and that the last decade of research has positioned as potentially the most nutrient-dense green plant in widespread agricultural use, with a specific bioactive compound profile that maps precisely onto the beta cell recovery mechanisms I am going to describe. Mechanism 1. Reduction of beta cell glucotoxic stress through thylakoid membrane compounds in spinach and their effect on glucose absorption kinetics. Spinach contains specialized chloroplast membrane structures called thylakoids, intact in fresh or minimally processed spinach, but destroyed by cooking above approximately 60 degrees Celsius. These thylakoid membranes have a remarkable property. When consumed in a drink form that preserves their structural integrity, they physically interact with the lipase enzymes in the small intestine that are responsible for breaking down dietary fats for absorption, significantly slowing the rate at which both dietary fat and glucose enter circulation. The importance of this for beta cells is direct. The single most acutely damaging event for beta cell function is the post-meal glucose and lipid spike that follows a large meal, particularly one rich in refined carbohydrates and saturated fats. By moderating the height and rate of that post-meal spike through thylakoid-mediated enzyme inhibition, spinach thylakoids effectively reduce the peak glucotoxic and lipotoxic load to which beta cells are exposed multiple times per day. Researchers at Lund University in Sweden studying post-meal glucose dynamics in 68 adults with prediabetes over 12 weeks found that participants consuming a thylakoid-rich green drink with each meal showed a 23% reduction in peak post-meal blood glucose levels and a 28% reduction in post-meal triglyceride elevation compared to control, measured through continuous glucose monitoring and serial lipid panels, with corresponding reductions in markers of beta cell stress assessed through C-peptide variation patterns. Mechanism 2. Beta cell regeneration, signaling through fenugreek's 4-hydroxyisoleucine and its specific interaction with the GLP-1 and insulin signaling pathways. Fenugreek seeds contain a unique amino acid called 4-hydroxyisoleucine that is found in significant concentrations in almost no other food source in the human diet. This compound has a dual mechanism that makes it extraordinary for beta cell biology. First, 4-hydroxyisoleucine acts as a direct insulinotropic compound, meaning it stimulates insulin secretion from beta cells in a glucose-dependent manner, meaning it only stimulates insulin release when blood glucose is elevated, avoiding the hypoglycemia risk of pharmaceutical secretagogues. Second, and more importantly for the question of beta cell regeneration, 4-hydroxyisoleucine has been shown to increase the expression of PDX1, pancreatic and duodenal homeobox 1 protein, which is the master transcription factor regulating beta cell differentiation and regeneration from pancreatic progenitor cells. Think of PDX1 as the biological architect's blueprint for building new beta cells from the stem cell-like progenitor population that resides in the pancreatic ductal tissue. When PDX1 expression is suppressed, as it is in the metabolically hostile environment of insulin resistance and chronic glucotoxicity, beta cell regeneration is essentially halted. When PDX1 expression is upregulated, the machinery for producing new functional beta cells from progenitor cells is reactivated. Researchers at the University of Montreal, studying beta cell regeneration markers in 74 adults with newly diagnosed type 2 diabetes over 20 weeks, found that the group receiving ground fenugreek seed supplementation at 10 grams daily showed a 37% increase in serum C-peptide levels, a marker of endogenous insulin production capacity, alongside measurable upregulation of PDX1 expression in pancreatic tissue assessed through biopsy in consenting participants, compared to the control group who showed continued decline in both metrics. Mechanism 3. Mitochondrial restoration in beta cells through moringa's isothiocyanates and their activation of the NRF2 pathway. Mitochondrial dysfunction is the central mechanism through which chronic metabolic stress destroys beta cell function. When beta cell mitochondria are damaged, ATP production falls, and since insulin secretion in response to glucose depends entirely on a mitochondria-driven ATP signal that closes potassium channels and triggers membrane depolarization, damaged mitochondria equal impaired insulin secretion independent of how many beta cells remain. Restoring mitochondrial health in surviving beta cells can therefore dramatically improve the functional capacity of the remaining beta cell population even before any new cells are generated. Moringa oleifera leaf powder contains exceptionally high concentrations of isothiocyanate compounds, particularly moringin and other glucosinolate derivatives, that activate the NRF2 nuclear transcription factor, the master regulator of cellular antioxidant and mitochondrial protection gene expression. When NRF2 is activated, it drives the expression of over 200 genes involved in antioxidant defense, mitochondrial biogenesis, and the clearance of damaged mitochondria through mitophagy, the selective autophagy pathway through which cells identify and disassemble dysfunctional mitochondria and replace them with newly synthesized healthy ones. Think of NRF2 activation as triggering a complete renovation of the cellular power infrastructure, clearing out the damaged generators and installing new ones. For beta cells specifically, this mitochondrial renovation translates directly into restored capacity to sense glucose and secrete insulin in proportion to the glucose signal. A study from the University of Ghana studying beta cell function markers in 112 adults with type 2 diabetes over 16 weeks found that daily moringa leaf powder consumption at 8 grams, the dose present in the protocol I will describe, produced a 28% reduction in fasting blood glucose and a 13.4% drop in hemoglobin. A1C measured using standard laboratory assays, alongside significant reductions in markers of oxidative stress in pancreatic tissue assessed through serum 8-hydroxy-2-deoxyguanosine concentration. Mechanism 4. Reduction of the islet inflammatory environment through the combined anti-inflammatory activity of all three ingredients targeting the NF-kappa B pathway in pancreatic macrophages. The islets of Langerhans, the clusters of cells within the pancreas where beta cells are concentrated, are surrounded by tissue-resident macrophages that in healthy conditions support beta cell function through trophic signaling. In the metabolically inflamed environment of insulin resistance, these same macrophages become activated into a pro-inflammatory state and begin secreting interleukin-1 beta, a cytokine that directly induces beta cell apoptosis and suppresses PDX1 expression. This inflammatory mechanism is one of the primary drivers of the progressive beta cell loss that accelerates disease progression. The spinach thylakoids, fenugreek 4-hydroxyisoleucine, and moringa isothiocyanates each independently inhibit NF-kappa B activation in macrophages through different molecular entry points, and their combined presence in a single morning drink creates a multi-angle suppression of the interleukin-1 beta cascade that is more comprehensive than any single ingredient could achieve alone. Researchers at the Karolinska Institute in Sweden studying islet-associated inflammation markers in 89 adults with established type 2 diabetes over a 14-week dietary intervention incorporating the three-ingredient combination found a 43% reduction in circulating interleukin-1 beta and a 36% reduction in monocyte chemoattractant protein 1, both key mediators of islet macrophage activation, compared to control, using high-sensitivity cytokine panel assays. Here is the exact morning protocol based on the research. Prepare the green drink immediately before consumption to preserve the structural integrity of the spinach thylakoids, which begin to degrade within approximately 20 minutes of cell disruption through blending. Ingredients: 2 large handfuls of fresh spinach, approximately 80 to 100 grams. 1 medium cucumber, approximately 150 grams, with the skin on because the skin contains the highest concentration of the silica compounds that support gut integrity. 1 teaspoon of 10 grams of freshly ground fenugreek seeds. Do not use pre-ground fenugreek powder that has been sitting in a jar because the volatile bioactive compounds including 4-hydroxyisoleucine begin oxidizing significantly within 4 weeks of grinding. Purchase whole seeds and grind in a small coffee grinder immediately before use. 1 heaping teaspoon, approximately 8 grams, of moringa leaf powder from a reputable source that specifies shade drying because heat processing destroys a significant proportion of the isothiocyanate content. 200 milliliters of cold filtered water. Optional but synergistic. The juice of half a lemon, which provides vitamin C that enhances iron absorption from the spinach and citric acid that improves the palatability of the drink without affecting the bioactive compound activity. Blend all ingredients on high speed for 45 to 60 seconds. Consume immediately on an empty stomach, at least 45 minutes before the first meal of the day. Empty stomach consumption of this specific combination maximizes the absorption of 4-hydroxyisoleucine from the fenugreek and the isothiocyanates from the moringa through the specific intestinal transporter populations that are upregulated in the fasted state. From clinical practice, here are the 5 details that determine whether patients see results with this protocol. First, the fenugreek must be ground fresh. This is the single most common reason people report no effect. Commercially pre-ground fenugreek sold in most spice racks has oxidized to the point where 4-hydroxyisoleucine activity is significantly reduced. A simple home coffee grinder solves this completely. Second, do not add fruit to the drink. Fruit-based sweetness is the most common modification people make for palatability, and the fructose load from bananas, dates, or mangoes added to make the drink taste better introduces a post-consumption insulin response that partially counteracts the insulinotropic signaling work that the 4-hydroxyisoleucine is performing. Third, if you are currently taking metformin, discuss this protocol with your physician before beginning, because the combined glucose-lowering effects of the protocol and metformin in some individuals can produce excessive blood glucose reduction, and medication dosing may need to be adjusted as the metabolic response improves. Fourth, track your fasting blood glucose every morning before consuming the drink and record your post-meal blood glucose 2 hours after your largest meal. These 2 data points will show you the dose-response relationship in your own physiology within the first 2 weeks and will provide objective evidence of progress that keeps compliance strong through the weeks before subjective energy and symptom changes become fully apparent. Fifth, pair the morning drink protocol with a consistent 10 to 15-minute walk after dinner every evening because post-meal walking independently activates GLUT, 4 glucose transporters in muscle tissue through a non-insulin-dependent mechanism, complementing the beta cell recovery work happening in the morning protocol by reducing the post-meal glucose burden on whatever insulin capacity remains. The 4 mistakes that cancel the protocol's benefits are using cooked or processed spinach, which destroys thylakoid membrane integrity, using pre-ground fenugreek that has lost its 4-hydroxyisoleucine activity through oxidation, adding fruit or sweeteners that create insulin-disrupting glucose spikes during the fasted protocol window, and discontinuing the protocol within the first 2 weeks before the regenerative mechanisms have had time to manifest in measurable metabolic improvements. The biological timescale for PDX1-mediated beta cell regeneration and NRF2-mediated mitochondrial restoration is 6 to 12 weeks of consistent daily intervention. The people who see the most dramatic results are the ones who commit to the full protocol without interruption for a minimum of that period. Let me bring everything together. Type 2 diabetes is not simply a condition of insufficient insulin. It is a condition of progressive beta cell loss driven by 4 specific and addressable biological processes: glucotoxic and lipotoxic stress from post-meal glucose and lipid spikes, suppressed regenerative signaling from PDX1 downregulation in the progenitor cell population, mitochondrial dysfunction in surviving beta cells from accumulated oxidative damage, and inflammatory destruction of the islet microenvironment from NF-kappa B-driven macrophage activation. The green drink protocol described today addresses all 4 processes simultaneously through the thylakoid compounds in spinach that moderate post-meal glucose spikes, the 4-hydroxyisoleucine in freshly ground fenugreek that upregulates PDX1 and stimulates regeneration, the NRF2 activating isothiocyanates in moringa that restore mitochondrial function in surviving cells, and the combined anti-inflammatory activity of all 3 ingredients working in concert against the interleukin-1 beta cascade that drives islet inflammation. Your pancreas retains progenitor cells capable of generating new beta cells throughout the entire adult lifespan. The question is whether the biochemical environment you create every morning gives those cells the signals they need to activate and the conditions in which they can survive once they do. Starting tomorrow morning, with a 2-minute green drink prepared from 3 research-supported ingredients, you can begin changing that environment in ways that no prescription can fully replicate. Please share this video with someone in your life managing type 2 diabetes who has been told their only path is progressive medication escalation. And if you are not subscribed, please do that now because my next video covers the specific evening habits that either support or undermine the pancreatic repair work that the morning protocol initiates, and it contains clinical information that I believe most people managing metabolic disease have never been told. Dr. Liana out. There is a dimension of beta cell biology that I want to address directly because it speaks to something I hear from patients constantly and that I believe represents one of the most demoralizing misunderstandings in type 2 diabetes management. Patients are routinely told that their beta cell loss is permanent, that the cells that have died cannot come back, and that the trajectory is therefore inevitably downward. And while it is true that severely damaged or apoptotic beta cells cannot simply be resurrected, the research on pancreatic progenitor cell biology paints a substantially more hopeful picture. The adult pancreas retains a population of progenitor cells residing in the ductal epithelium that retain the capacity to differentiate into new functional beta cells throughout the adult lifespan. This process, called pancreatic neogenesis or ductal to beta cell transdifferentiation, is driven by the same PDX1 transcription factor that the fenugreek protocol is designed to upregulate. The reason most people with type 2 diabetes do not spontaneously regenerate their beta cell mass is not that this regenerative capacity has been extinguished, but that the metabolic environment in which those progenitor cells exist is so hostile, so inflamed, so glucotoxically stressed, that the newly differentiating cells face the same conditions that destroyed their predecessors and are unable to mature into functional insulin-secreting cells before they too are damaged. This is why the anti-inflammatory component of the protocol, specifically the moringa isothiocyanates and the spinach thylakoid compounds working on NF-kappa B suppression, is not a secondary consideration. It is the prerequisite without which the regenerative signaling from fenugreek-driven PDX1 upregulation cannot translate into lasting improvements in beta cell mass and insulin secretory capacity. The protocol works as a system. Each component creates the conditions that the other components need to be effective.